Good morning, ladies and gentlemen, distinguished guests and future scholars. Welcome to the Faculty of Engineering, Built Environment and Information Technology, or EBIT in short. I am Professor James Maina, the Deputy Dean for Research and Postgraduate Studies at the Faculty of EBIT. Thank you for the opportunity to introduce our faculty to you. The presentations you will hear today are a snippet of what the faculty has to offer. Please visit our website for more information on different research areas in the faculty. Artificial intelligence, machine learning, robotics, smart cities, and big data are dictating the future of work, the future of education, and ultimately our survival. The heartbeat of the Faculty of Engineering, Built Environment and Information Technology is innovation. Innovation is our business. Not only innovation that leads to real-world change on the outside for the good of humanity and the planet, but also innovation from within. While technology is the catalyst for change in the workplace, humans are the sustaining force. So as technology evolves, humans need to develop new mindsets and find new ways of working. Our slogan, "Innovating Our Tomorrow," keeps us on the path of pursuing innovation. We will remain relevant and address the challenges of the future of work with a generation of problem solvers and innovators who are ready to change the world and create a peaceful and more sustainable planet. We will achieve this by, among other things, embracing Society 5.0, leveraging the possibilities, prospects, and challenges of digital transformation. It is my privilege to introduce Professor Steyn, the Dean of the Faculty of Engineering, Built Environment and Information Technology, to you. Professor Steyn will give us a broad overview of the faculty.
Thank you very much, Prof Maina. I appreciate the introduction. We are extremely proud about the work that is being done by students, staff, researchers in various spaces in the EBIT faculty. And the outcome of this really good work we can see in the international rankings that tells us that in various subject areas we are actually pretty good at what we are doing. So if you come to study at the University of Pretoria, specifically in the EBIT faculty in this case, you can be assured that the work that you are doing will be significant, it will be important, and it will be highly ranked. And the day you walk out of here with a qualification, that qualification will be valid and recognized and accredited to go and do your job anywhere in the world. But we hope that you do a major part of that in South Africa to benefit our communities also. So you guys are coming to study to prepare you for the future of work, for tomorrow. And how do we do that at EBIT? It's important to understand firstly that future of work means that life and work will be evolving, it will be blended, it will be indeterminate and transformative. And actually, in a nutshell, we don't know what it all will be like. It will be a surprise. So how do we prepare for the surprise? Through continuous learning. Most of you will have done a first degree or first qualification already, and that's what I see as your base skills, the fundamentals. You know the basics that it's all about. But then life does not stop there, at least your learning life. Because what happens with your technology and your field of discipline? It's adaptive, it's transformative, it's evolutionary. There's novel development, stuff that we don't know today when we are doing your base skill training. So how do we make sure that we pick up these skills? One of the areas that we at EBIT is picking up a lot is through immersive learning. Immersive learning is when you've got experiential training through things like virtual reality, where we simulate the real world and we make sure that in a safe and engaging way, you can start to apply what you are learning and training. One of the good examples of that is in our mining engineering department, where we've got a whole facility engaging in virtually taking you inside a mine, safely engaging, and you learn a lot through that. So through all of this, what difference do we make? If we look at our 4 schools, engineering, built environment, information technology, and GSTM, I would like to summarize it as follows. The engineering department of school looks at how to develop stuff to support life, because we need to be important for communities. The built environment school look at the places to support life. Where do we place various facilities? How do they link up with each other? And how do we make sure that these buildings and facilities are high quality? After we've got stuff and places, we've got a lot of information. And the School of Information Technology looks at how that information supports life, whether it's information on your health, it's information on building technologies through digital twins, it's information on whatever you are busy with, because that's the world of tomorrow. They also make sure that your information is safe. And then lastly, the Graduate School of Technology Management assists us to manage the processes of new technologies, new innovations, and how do we prepare for our tomorrow to make sure that when you walk out of here with this qualification, it's not the last time that we see you. You will return for continuous learning, but you will make a difference in your community.
Thank you, Prof Steyn. Please come and join us here. So as you heard, EBIT is highly ranked, and we have international research collaborations and accreditation. Oh, we've got also here Jordan, and Jordan has got a surprise for us in terms of Smooth. Prof Steyn, can you please engage Jordan with Smooth?
So, this is my opportunity to say welcome to Smooth and to Jordan. Jordan is, apart from being a technologist, he's the dog handler, which is an extremely important job in our department, school, faculty, and actually the university. We procured Smooth about 2 years ago, and Smooth is doing a lot of work as a valuable staff member at UP. Jordan, can you tell us what Smooth is busy with now?
Thank you, Prof. So at the moment, electronic nose is being developed for Smooth, which could be mounted on his back and then connected to him. And then Smooth could be programmed to detect certain scents in the atmosphere and then track it, similar to a sniffer dog. Another project that Smooth is also working on is where various sensors are going to be mounted on his back and sent into a crime scene investigation. And that will be you'll enable him to collect data off the crime scene without contaminating it, and therefore ensuring that the scene is safe for investigators to go in. Thank you, Smooth.
That sounds good and cool, Jordan and Smooth. I think Smooth is off to work. Thank you very much. Enjoy.
Thank you, Prof.
Thank you, Jordan.
We are the generation.
We are the problem solvers.
We are the innovators. We change the world.
We keep reinventing ourselves,
To remain relevant.
and compete globally.
creating a peaceful and sustainable planet for all humans.
Wow. So, and this is what EBIT is all about, and across the 4 schools that the Dean of EBIT, Prof Steyn, spoke about, these are 6 areas that EBIT focuses its research on and contributes significantly to addressing the societal challenges. And if you wonder, how do we measure the impact of our research work? A widely used approach is to look at the contributions to the 17 Sustainable Development Goals, or SDGs in short. The SDGs were adopted by the United Nations in 2015 as part of the 2030 Agenda for Sustainable development. So the 17 SDG goals are a call for urgent global call to action to end poverty, protect the Earth's environment and climate, and ensure that people everywhere can enjoy peace and prosperity. So I'll briefly present contributions of the 4 schools to the SDGs. These contributions were scientifically quantified using artificial intelligence, tools based on machine learning and deep learning. And these tools were used to evaluate more than 4,000 of EBIT publications between 2015 and 2022 and determined their contributions to the SDGs. So as shown in the radar chart to your right, scientific work from the School of Engineering, or in short SOE, in the last 80 years has contributed significantly to SDG 7 on affordable and clean energy, SDG 9 on industry, innovation and infrastructure, SDG 12 on responsible consumption and production, as well as SDG 13 on climate action. On the other hand, scientific work from the School of Built Environment, or in short SOBE, has contributed significantly to SDG 9 also on industry, innovation and infrastructure, SDG 11 on sustainable cities and communities, SDG 12 on responsible consumption and production, as well as SDG 13 on climate action. Then scientific work from the School of Information Technology, SIT, has contributed significantly to SDG 4 on quality education, SDG 9 on industry, innovation and infrastructure, as well as SDG 17 on partnerships for the goals. Similar to the School of Engineering, the scientific work from the Graduate School of Technology Management, or in short GSTM, has contributed significantly to SDG 7 on affordable and clean energy, SDG 9 on industry, innovation and infrastructure, SDG 12 on responsible consumption and production, as well as SDG 13 on climate action. So if we combine the contributions from all the 4 schools, this is what we get as the combined EBIT research contribution to the SDGs in the last 80 years from 2015 to 2022. So, and I hope you will make a decision to come and join us at UP. And if you join us, you will never walk alone during your postgraduate studies, because there are several support systems such as Graduate Support Hub, Postgraduate Scholarship Office, Fly Higher at UP program that are there to make sure you succeed. We look forward to traveling with you in your postgraduate studies journey and beyond. It is my pleasure to introduce Professor Hanley Smuts, the head of the Department of Informatics in the School of Information Technology.
Thank you very much for the introduction, Prof Maina. I would like to talk to you about humanizing technology and specifically tell you about the research projects that we do in our Informatics UX lab. Now, technologies are emerging and evolving faster than the capacity of some of our organizations to adopt, and therefore it demands a nimble response. So furthermore, the rapid development of connected technologies, which are now highly sophisticated, brought with it a dramatical societal shift. And that is really a vision for the future that hinges on digitalization, AI, and the trusted sharing of data. But what does humanizing technology and technology for the benefit of all people mean in this context? Technology should focus on reducing the complexity of daily lives, and it must empower nations, organizations, and citizens to follow the path of digital transformation. Advancing technology needs to become more human-orientated to help us to streamline, simplify, evaluate, and filter, and to better understand human needs and emotions and human behavior. So technologies will come and go, but the human, in this context, is the only constant, and using technology as a means to enable the needs of human beings. Therefore, there are 5 human experience considerations in the context of technology design. The first is to promote inclusion. The speed at which technology is changing bears the risk of excluding less tech-savvy people from its usage. Further to understanding and interrogating the cultural and social impact of new technologies, also consider inclusion in driving the creation of new technologies, methodologies, and information systems. And that leads us to the second aspect, which is foster the sense of community. So humans are social creatures. Lockdown and social distancing requirements during the COVID-19 pandemic amplified our need to connect, to engage, and to belong. Technologies has created a global village where it is easy to engage with anyone, for example, with experts. The third aspect is to know your user. The recent focus on UX and UX design highlighted the emotional side of human experience. Each user has a unique preference, behavior, and expectation. So emotion appeal is key to any human-computer interface, and more so for design assets that intend to bring back users again and again. Furthermore, there's a strong connection between emotions and recall, so design to produce those positive emotions. The fourth aspect is simplicity. Keep it simple. Minimize the number of concepts in an engagement step and reduce short-term memory load. So that means do not expect users to remember sequences of actions or data carried over from 2 steps back. Furthermore, digital technologies now provide tools for visualization, so think about whether a paragraph or text may be replaced with an image. And finally, understanding mental patterns. No 2 people think exactly the same way, and we are a product of different thinking patterns that emerged as a result of our experiences of interacting with reality. So users may therefore try to deploy mental patterns developed from doing tasks in the physical world to the online world. So as it takes time to change these patterns, ensure a good understanding of your user's mental patterns and then replace it in an intuitive user interface. The ironic part of the context of these 5 human experience considerations is that technology changes faster than the human needs it is supposed to serve. We therefore also need to understand our responsibility related to this great power of technology by anticipating challenges and by asking critical human-centered questions before making user interface decisions. This is where we apply the design thinking processes and human interface evaluations through eye tracking in our user experience lab at University of Pretoria and in our faculty. Humanizing design experiences may sound intangible, but it is very powerful. Make sure you design for impactful human experience by ensuring that human-machine engagement is as easy and emotionally connected as a conversation between 2 friends. We are looking forward to seeing you here.
Humanizing technology. What a wonderful concept. But these are 2 words one would not have put in the same sentence, and yet here they are. Thank you, Prof Smuts, for explaining this concept to our audience. Our next speaker is Professor Venter, the head of the Department of Computer Science, who will now invite you to become part of his research group called Digital Forensic Science, DigiForce, in the Department of Computer Science. Thank you, Prof Venter.
Thank you, Professor Maina, for the introduction. Ladies and gentlemen, distinguished guests and future scholars, thank you for joining me today. I am here to introduce to you the fascinating world of digital forensic science and the incredible opportunities that await you within our research group, DigiForce. I'm Professor Prof Venter, the Director of the Digital Forensic Science Research Group. I'm assisted by my truly diverse team, Professor Martin Olivier, Dr. Moses Lamini, Mr. Avinash Singh, Mrs. Stacey Barrer, and Mr. Mark Makura. Imagine a world where the digital realm is secure, where cyber criminals are held accountable for their actions, and where individuals and organizations are safeguarded from these online threats. This vision is what drives our Digital Forensic Science Research Group, DigiForce. At DigiForce, we are at the forefront of digital investigations, pioneering new techniques and technologies to tackle the ever-evolving challenges of cybercrime. Our mission is clear: to improve the lives of all humankind by ensuring digital spaces are safe and secure. Now let's delve into the 5 life skills that students can acquire by studying with us at DigiForce. I will introduce each one separately in the next few slides. In our digital age, the ability to identify cybercriminals is more critical than ever. Our students learn to dissect digital footprints, trace malicious activities, and uncover hidden threats. By acquiring this skill, they become digital detectives of our time, contributing to a safer online environment. Digital evidence is the cornerstone of any successful prosecution in the cyber world. Our students are equipped with the expertise to collect, preserve, and analyze digital evidence effectively. They become the bridge between technology and justice, ensuring that wrongdoers are held accountable for their actions. In the fast-paced world of cybercrime, innovation is key. Our research group is dedicated to developing cutting-edge forensic techniques. Students here are encouraged to think creatively, pushing the boundaries of digital investigation. By joining DigiForce, you become part of a community that shapes the future for digital forensics. Prevention is often the best defense against cyber threats. Our students become ambassadors of cybersecurity awareness. They educate individuals, businesses, and organizations about the risks in cybercrime, helping them protect their data and resources. Knowledge is power, and our students empower others to stay safe online. Ultimately, our mission is to protect people from the devastating effects of cybercrimes. Our students learn not only the technical skills, but also the ethical responsibility of ensuring the safety of others. By studying with us, you become a guardian of digital well-being, making a tangible difference in people's lives. In conclusion, DigiForce is not just a research group. It's a gateway to a world where you can make a significant impact on society. By joining us, you'll gain the skills to identify cybercriminals, gather crucial digital evidence, innovate in the field, educate others about cybersecurity, and protect individuals and organizations from cyber threats. Studying for a master's or doctoral degree within the DigiForce Research Group will not only change your life, but will also empower you to change the lives of countless others. Together we can build a safer, more secure digital future for all humankind. Thank you for your attention, and I invite you to explore the exciting opportunities that DigiForce has to offer. together we can shape a brighter, digitally secure world.
Thank you very much, Professor Venter, for your presentation and for assuring all of us that a safer and more secure digital future is possible. Ladies and gentlemen, we still stay in the digital world as we invite Dr. Khaled Davey to tell us more about future smart cities.
Thank you, Prof Maina, for the introduction. My focus is on the intersection of technology and city development in Africa. Specifically, I want to explore how technology can help us create thriving future cities. My main project is the Hatfield Digital Twin City Initiative. We're using digital twin technology to build virtual replicas of our city. But these aren't just static models, they're dynamic, real-time environments. Think of it like Google Maps, where we receive live data and make decisions in real time, which in turn affects the digital twin of traffic. Now imagine extending this concept to an entire city. We collect various data, plug it into our digital twin city platforms, and create real-time tools for city management, design, and planning. This benefits not only city planners, but also governments, communities, and citizens. Our initiative covers a 25 square kilometer area around the University of Pretoria campus. Students and researchers are actively involved in building this virtual city, capturing both visible and invisible data, everything from weather systems to social systems. This project allows us to address critical questions about the future of African cities. How can we go beyond the fourth industrial revolution? What is the future of a thriving African city? How can we create low-cost solutions for very complex problems? Can we simulate circular economy and learn from it? And what does a real smart city look like in the future of Africa? This is a transdisciplinary initiative involving experts from various fields. Students and teachers and researchers are all part of this city laboratory, and we invite you to join us. Together, we aim to discover how we can use technology to generate more value in African cities.
What does the future hold, you may ask? Nobody can exactly predict the future, but do we sit still and wait for the future to happen? No, not especially at the University of Pretoria. We innovate, we find solutions, we anticipate and do future-focused research to stay relevant and make today matter. In closing, I would like to introduce Professor Jacobsz from the Department of Civil Engineering, where they are disrupting the norm.
Thank you, Professor Maina, for the introduction. Good day, ladies and gentlemen. The mining industry is still the single largest contributor to the South African economy. An important impact of mining is the production of vast volumes of tailings or slimes, which is a waste product comprising ground-up rock powder suspended in water. These are typically disposed of on tailings dams. Tailings dams are some of the largest structures made by man, often measuring kilometers across and sometimes extending to heights of several hundred meters. Tailings dams are a familiar feature in the South African landscape, as illustrated by numerous dams visible in the Google Earth image of the Witwatersrand. Newly deposited tailings must be allowed to consolidate and dry out sufficiently to ensure that it has got enough strength to accommodate more material which will eventually be placed on top of it. If tailings dams are not raised correctly and not enough time is allowed for the strength gain, serious stability problems may occur, resulting in catastrophic failure. Around the world, such failures are currently more common than what society is prepared to tolerate. The mining industry is therefore under intense scrutiny to verify the stability of their tailings dams. This often requires the taking of tailings samples from dams and testing these in a laboratory to determine the properties of the material. Unfortunately, mines and testing laboratories are often hundreds of kilometers apart, And by the time that the sample reaches the laboratory, it is often completely disturbed, leading to unrepresentative soil properties being measured and giving the wrong impression of the stability of the dam in question. The University of Pretoria, in collaboration with Anglo-American, have established the state-of-the-art mobile soils laboratory, which will enable sensitive samples from tailings dams to be tested where they are taken, thus avoiding sample disturbance associated with long-distance transport. The laboratory is housed in an 8-ton truck and is equipped with 4 advanced triaxial test systems, 2 dynamic cyclic shear systems, and an automated odometer system, as well as the necessary supporting equipment. 2 of the triaxial frames are intended for the measurement of critical state lines, and 2 more are fitted with local strain instrumentation and bender elements, which will enable tailings brittleness studies to be carried out. The direct simple shear equipment allows samples to be loaded in near plane strain simple shear, which more closely represents the mode of shear in actual dams than triaxial compression, and also allows cyclic soil behavior to be studied. The laboratory is powered by a solar power system to operate completely off the grid. A backup power generation is provided to accommodate prolonged overcast weather. Provision is also in place to draw power from the grid when and where it is available. The laboratory will be staffed by 2 experienced technicians and will be based at the university's Engineering 4 complex on the Hillcrest campus. When not working on site, the facilities will be used for geotechnical research by the geotechnical group in the Department of Civil Engineering. In addition to the university's existing geotechnical research facilities, such as the only active geotechnical centrifuge on the African continent, this mobile laboratory places the University of Pretoria in a unique position to contribute significantly to advance the state-of-the-art in the important field of tailings engineering.
Thank you very much, Professor Jacobsz. This explanation of the need for the mobile soils laboratory and the impact it has on the continued existence of our mines is indeed enlightening and an innovative solution. We are extremely proud of our researchers at the Faculty of Engineering, Built Environment and Information Technology who care about the society and often engage in transdisciplinary and interdisciplinary research to engineer a more sustainable planet for all humankind. Please visit our website and contact us if you want to be part of the EBIT generation who makes today matter through innovating our tomorrow. Thank you very much.